All right, so if you looked at our video from last week and we actually worked through problem 1, so what I would like to do is take a look at problem 2 and see if we can come up with a solution for this particular problem. So I'm just going to copy this and I'm going to put it into a Word document or a text document of some kind. And I just prefer for this, I'm just going to use Notepad. It's light and easy. Again, I have several people saying they have Notepad+++, plus or whatever it is. That works fine. If you use that for a coding class, you can certainly use it for this particular course. So what's the first thing that stands out in this problem? So just to get in the habit, we're going to put a start stop or a start end. So some kind of a terminator connector, some way we know. And so then, and I don't know if Notepad will do this anymore. I'm used to some other tools. Oh, no. All right, so Notepad++, you can highlight and tab an entire group. This, you're forced to do it by one at a time. So it takes a little more time to get that set up. But this shows that our start and stop, this is all a block internally there. All right. Oh, I forgot I was going to do the LAN school and see if I could share that window out with you guys. So online this obviously won't work, but show. So did you guys get a copy of my screen then? Nope. Yes? And you can see the coding? No, it's on the wrong one. All right, hang on a second. Trick to that. How did I have to do that? Bring it over here. All right, now do you see the screen? You're still getting just the blue one? All right, I may have to experiment with that a little bit. Let me see if there is a way to... The two monitors up here I know has been a problem. I'm trying to remember how we solved it before. And that you still get the blue screen, don't you? Alright, I'm going to experiment a little after class here so we don't waste a whole lot of time. The LAN School is an interesting product we use in here, but we haven't bought the updates for the last couple of years, so it has some restrictions. So, first catch, we know that we need to do the start stop. So, really nothing in the comments that's going to say anything that's going to change anything. So remember, anything after the // is just purely a comment, so it's not going to do anything. So, to be really honest about what we're going to do, if we're going to get completely technical, we really should declare miles traveled. And again, that garbage collection would say we'd want to put that in as a 0. So it's a numeric. So on this first homework, I'm not so critical about these to start with. And then gallons of gas used, and we're going to set that equal to 0. And that's just that garbage collection routine. So we set those up. We declare it so we know we're using those two variables. We know they're both numeric variables or numbers of some sort. So input miles traveled, input gallons of gas used. So what's the next error or weird issue we have in this code? What have you guys ran into? Thank you, sir. All right, did anybody not sign the sign-in sheet today? All right, if you'll come grab that and make sure you're signed in, please. what other errors are there in this particular program? Are there any errors? No. So actually, I heard a couple of different things. So miles per gallon is really not gallons used divided by miles. That would be gallons per mile. Well, and if your vehicle takes more than 1 gallon a mile, well, you're probably got an issue. So we need to flip those around, right? But there's another issue with that line. What's the other issue in that line? So travel's misspelled. Okay. What else is wrong with that line? Correct. All right. So I'm actually going to make a blank line and start this one over. Whenever we assign a value into a variable, we use the equals sign. That equals sign really is an assignment operator, and it says, I am putting the stuff on the right into the variable on the left. And so it's, if you think about it as an arrow, always pointing to the left. So really what we need is miles per gallon is equal to something. And so we hope that it's actually miles traveled divided by gallons of gas used. Now, I'm going to eliminate this line. And white space is free. You can always put in spaces in white space vertically like this. Doesn't hurt anything, and if it makes it easier to read. So then we are going to, it says we're going to output miles per gallon. All right, any problem with that line? To be gallon. And those are the kinds of problems you're going to run into. So now we got this program all fixed, right?
What if you have the miles per gallon after the down? Yeah,
okay.
The second go up one. Yeah, what if you have miles per gallon after?
It would not work correctly. It has to be the variable we are assigning a value to has to be on the left-hand side of that equal sign. There is no programming language that I know of off the top of my head that it's not true. So it really isn't an equals. It's really an assignment. You say you're taking whatever your calculation is to the right of it, and you're shoving it in there. So there's one more problem I see with this. What might be an issue with this? So let me give you a hint. How many variables did we use in this program? How many variables did we declare? Oh. Correct. So if we're going to use a variable, in almost every language we need to declare it. So we need to declare miles per gallon, and then we just set it equal to 0. So what this also does is gives us a really quick at the top here. That's all our variables. We know that those are all in there. And we can even do the little copy and paste to copy and paste those names in later. So we make sure that we don't have a spelling error. Puts them in a really nice, neat little place. So when I glanced through, and I did not assign grades for most people, I just started on it last night at some 2 in the morning. What I discovered is a lot of people got this wrong because they left it as that equals and put the miles per gallon on the right hand side. You corrected the fact that it was gallons divided by miles. You got that logical piece, but it seems like it wasn't very clear that we have to always start on the left hand side with that variable. So left hand side. All right, so I'm going to put a little note up here for me so that this is number 2. All right, so is that the only way to have solved that problem? No. You could have used different variables. You could have changed it. But I think that's a fairly descriptive way, and it's got all the pieces that we wanted to look at. So we declare our variables. We're clear in our variable names. They make sense. Yes, sir.
I can still see like half your screen on the computer.
Is it dry? Okay, hang on. I might probably have that on still. Let me see if I can fix that. That make it go away? All right. All right. We'll have to figure out how I can get flipped from one screen to the other because it's not very clear in here. So that's how I would solve that problem, or one solution for it. So in this first case, if you don't have the declarations, because our book doesn't really get a whole lot into that, I'm probably not going to count any points off for that. What I am going to count off for is, did you make sure you turn this around? Did you make sure the variable names all matched? Next assignment, you need to make sure you declare all your variables. If nothing else, then it gives you a handy spot as a resource to go up and look and say, hey, I know what all my variables are in this program. All right, so let's look at number 3. And I'm going to grab the code for that real quickly. All right, so we'll give away the first piece. So just like, I'm going to put a start, stop, and then we're going to copy and indent all those real quick. All right. So what kind of problems did we have in this code? Is it all perfect? No. So first thing I'm going to do, I see a variable, and I'm going to look at it, and I'm going to put in num total dollars spent. I'm going to set that equal to 0, just so we don't have any garbage in there. And then the next line of the program tells me we have one about days on trip. So num days on trip. Again, I'm going to set it equal to 0. Just, I don't know what else is in that computer, what's been used on it. And it looks like we have another variable that says cost per day. Cost per day equals 0. Holy cow, this program has a lot of variables. Total, so total money spent. Alright, so I'm going to stop there for a second. What kind of issues do we have with this to start with? Is there an issue anywhere in the first line? We're inputting total dollars spent. That seems to make sense. You're trying to describe how much it costs per day and how much it costs per week for a vacation. So one of the questions I had, is this up here going to cause any issue? No. It actually isn't, and you could simply fix it that way, or you could eliminate them, or you can actually have them both in there. In most languages, a second set of comment tags isn't going to hurt anything. So here we're going to input how much you spent on a trip, and here we're going to put in how much days you spent on the trip. So if we're going to figure out what the cost per day and the cost per week is, does that give us enough information to solve this problem? Okay. So now we need to do some computation. And so it looks like we're trying to figure out the cost per day equals total money spent times days on trip. I probably would. So, because if I multiplied that, that would get very expensive very quick. So we have a slash in there. Anything else wrong or that we need to deal with on there? Oh, so instead of total money spent, total dollars. And those kinds of things will drive you crazy when you're creating your own code. I thought I said, and your brain will interpret that as the same. So cost per day equals total dollars spent divided by days on trip. So if I spent $700 and I spent a 7-day trip, I spent $100 a day. Well, that makes sense. So the next one says weeks equals days on trip. Okay, so we need to num weeks equals 0. So we know it's a clear variable in there. Does that math look right? Does that look right? If I want to know how many weeks I'm on a trip, and I say I'm on a trip for 30 days, I divide it by 7, I find I'm at 4 point something number of weeks, right? Okay. And we're not going to worry about where it rounds off or anything yet. We'll just assume that you magically have an easy number. So cost per week equals days on trip divided by number of weeks.
The variable weeks should be number of weeks instead.
So you think we should use, just to make it clear, number of weeks? Is that what you think right there?
Yeah.
Okay. That probably does fit the scheme that they've got a little better. So let me type that one. Alright, so that seems better. But does that seem right to me? What else could we do to fix this? What would we need to do to fix this particular problem? If I want to know how much it costs me a week, cost per week equals, okay, so you want to replace days on trip with, no?
No, in a different line.
Okay, hang on. So we want to start a new line?
Yeah, that's right.
Okay, so we want to call it
Cost per week. Is that what you're trying to calculate?
how much it costs you per week. That's what you're supposed to output is the cost per day and the cost per week.
Total dollars spent
Okay.
divided by number of weeks. Which is the same that you have now.
So does that look like it's going to give us a cost per week? So here's total dollars spent. So we spent $700 and we were there for 4 weeks. Is that going to give us our cost per week? So if you're going to do that, we could just eliminate this line down here then, right? Okay. So there's an alternative way that I think is kind of clever that might make the life a little easier. So another way to get cost per week, do we know how much it is per day? So if we know how much it costs every single day, could I figure it with multiplying? Cost per day times 7. Would that effectively give us the same thing? Yeah. Now what it does though, it creates a problem. It gives us that mystery number. Do we know where that 7 came from? So quite frankly, this seems like a better way to do it because it's a little more explanatory. What if we ran into somebody who didn't know that there were 7 days in a week? And you laugh at that. There are people that you will meet that don't know there's 7 days in a week. And they're not just first graders. So you could do another variable up here and say week equals 7. This is probably as clean a way to do it as any other. I had some questions about this output. Can I put 2 outputs on a line like this? Cost per day. And you could certainly do 2 outputs. Now there's something else wrong in here. What else might be wrong on here?
Week.
So it's really cost per week, right? So you're outputting those. And this is pretty simple. We're not dealing with formatting it. We're not making anything pretty. It just says we're going to output how much it is a week. So that's what we're talking about, this logic. We want to start figuring out that logic. So if that's the case, let's do problem 11 or
Did you
what?
say that number of weeks is also an output?
Cost per week, cost per day, cost per week.
Number of weeks.
Did it? Computing the cost per day and the cost per week for vacation. It doesn't actually ask us to output that. It really just says the cost per day and the cost per week.
What if you have it?
It wouldn't hurt anything to output it. It would not hurt anything. All right, so let's look at number 11. Well, let's just take a look at what we're going to do. So it says develop the logic of a program that allows the user to enter his or her hourly pay rate, the number of hours worked this pay period, and the percentage of gross salary that is withheld. The program multiplies the hourly pay rate by the number of hours worked, which gives us gross pay. It then multiplies the gross pay by the withholding percentage, subtracts that from the gross pay, giving the net pay after taxes. The program displays the net pay. All right, so I'm going to scroll down a little bit, give us some white space to work with here. So first thing I'm going to do is I'm going to put my start in, and I'm going to put a stop or an end. So I've created a program All right, so I've got a program that's going to compute net pay. So the first thing I'm going to think about is it says I'll use the user to enter his or her hourly pay rate. All right, so I've got to come up with a variable for pay rate. Well, I'm going to just declare that as pay rate. I'm going to set it equal to 0. And if I have pay rate, I need to know what else. To figure out what you make at a job, what else do you need other than what you make an hour?
Hours worked.
How many hours worked? So, hours worked. And there isn't any magic answer. These variables could be different. All right. We also are going to input one more thing. And what's that?
Percentage withheld.
Percentage withheld. So number. So I know we need these three variables. And from those already, we know we can input pay rate. And I'm actually going to combine these. You don't have to. They could be on a separate line. Just to make it a little shorter in here, I'm going to combine those. Hours worked and percentage withheld. So now the computer's got those three numbers in there, right? So you put in, I make $45 an hour, I worked 40 hours last week, and I lose 50% of my pay. Maybe, whatever it is. So now what are we going to do to calculate it? How do I calculate how much my gross pay is? So you're working for $10 an hour, you got a great part-time job, you worked 20 hours. How much money did you make last week? Okay, so we have another variable we're going to have to add up there. So let's say gross pay, we'll just call it. And that's equal to hours worked times pay rate. And now before I forget about it, because I know I created another one there. number gross pay equals 0. All right, so now we've computed gross pay. So we're making $200. So the next piece we have to do is multiplies the gross pay by the withholding percentage, giving the withholding amount. So withholding amount is equal to, so gross pay got it. Now, that means we have another variable in this program. So equals 0. So we're just declaring another variable. So now we've figured out, and you can put notes at the end of that that says gives me total pay or gross pay or whatever. You can put notes at the end of a line also. Or you could put one ahead of it and say, this is where we get the values, this is how we input. All right, so, yes? Oh, I do. Sorry. Trying to type and talk at the same time. We'll always do that. So I'm just declaring another numeric variable there. All right. So now we've got the withholding. We know how much that is. So program hours, give the gross pay, then it multiplies the gross pay by the withholding percentage, giving the withholding amount. Finally, it subtracts the withholding amount from the gross pay, giving the net pay. So we could say net pay is equal to our gross pay minus and again, because I created a new variable, and sometimes it's helpful to sketch these out and you can write those variables up. And so then now we have net pay, and this program says we want to display the net pay. So output net pay. And we've solved the problem. But when you first started this, would you have thought you would need 6 variables to solve one quick problem? Now, there's other ways to do this, but this is one representative way of how you might be able to solve this problem very, very easily. So what we're trying to get you to do is break down these problems into logical pieces and be consistent with your variables and your naming. So notice all of our variables used what we call that camel case. So that is actually what Python likes. So it makes our life a little easier if we utilize the same thing. All right. So I'm going to tuck this over here and save it for a little bit. So this book we will actually use for the next several weeks. So it's listed in week 1, but if you download it somewhere, or you just remember I need to go back here and grab it really quickly. All right. I did not look at how many people took the quiz. So if you haven't taken the quiz, go make sure you do that really, really quickly. But what we want to look at is week 2, marching along. So week 2, well, here's a surprise. It's week 2 of the book, or chapter 2. And chapter 2, we start looking at the idea of structure. And we're going to introduce you to every piece of programming construct we'll need. So if you think about programming languages like Lego blocks, we're going to give you all of the pieces of the blocks. So slide 1, we give you the entire chapter. So we're going to talk about structured code and what the difference is. But we have 3 basic structures. everything that we build, so Microsoft Windows, Mac OS X, Microsoft Word, everything on your phone, Tender, Liam, is all built using the same idea of these three things. It's either a structure, or it's a sequence, a selection, or a loop. That's all we have. 3 pieces, 3 Lego blocks. Everything we do is done with that. So you guys are thinking, man, this course may get hard. But you only have to know 3 things. 3 things. A sequence, a selection, and a loop. All right. So now there's some pieces behind that. So we're going to talk about what a priming input is. And that's probably the strangest thing we do in here the entire year, is this thing called a priming input. Telemarketers are active today. So we have to use a priming input. We have to talk about why we need structure. And we're going to work on structured versus unstructured, what the two look like. So if it's not structured, in other words, we'll talk about what those formal pieces are. So if I can't connect it like Lego blocks, so I connect each different structure like Lego blocks, top to bottom, it's called unstructured. We also, you may hear the term spaghetti code. And until the last few years, we had some really unstructured programming going on. And so we're trying to make life a little easier for the world in general. And some of that unstructured code has worked for numbers of years. And in fact, if you guys would have been lucky enough to be born 20 years past, and you would have went into school and you would have done something like a basic class where you had jumps and loops and all these weird things, we made unstructured code on purpose. But now we've kind of come to the light and we said, aha, if we're going to use this objective code we're going to do and some other pieces, and I make it like Legos, life is a little easier. So, to make it easier, we have to talk about each one of these types. So we're going to talk about sequence, selections, and loops. So that's the only 3 things we can do. There's no other magic pieces in there. There's 3 things we can do. We can write a sequence, we can write a selection, and the other term for a selection would be a decision. We can ask a question, and we can make a loop. So the power of this really is the loop, because that computer, we can make it do things over and over and over again. So that's kind of the powerful tool. We've already worked on sequences. So when we created the how to compute your net pay, that's a sequence. It's activities in of any kind, but they're in a specific order. I can't change them. They have to continue one by one by one by one right after each other. So that sequence can be any length. Doesn't matter. It could be 1 statement, it could be 1,000 statements, but they're going to happen one right after another. There's nothing else they can do except one follows another. It's the simplest structure we have. You guys have already started to work on it. You guys were able to now create pay and do all these other things, all using a structure. We started breaking programs down into that. So the one we haven't done a lot with is this one, a decision. And you may have seen, so on the right-hand side is a flowchart symbol for a decision. It's that diamond. And that diamond really has 2 outputs, a yes or a no. Why can we only have 2 outputs? Why don't we make it like a pentagon and have like 3 or 4 or 5 outputs? Why are we limited to 2 outputs? What's the limiting factor in there? Binary. Somebody said it over there. Our computer is really dumb. It's binary. It can only do either a yes or a no, a 0 or a 1, on or off. So the other way we've heard those described, or another way to talk about them is an if-then-else structure. Your parents used to give this structure to you. If you don't get grades that are acceptable, you are going to have some form of punishment. Did any of you guys get that at home? But you gave it? So my 8-year-old right now has decided that she doesn't need to do math in school. So she got this lecture last night. If you don't get your head out of your rear end and do your homework at school, you don't get to go BMX bike racing this year. So it's an if-then statement. So if a condition is true, something will happen. So if I look at my structure up there, I come in and I say, if my child's grades are not A's or B's, then yes, she is going to have a consequence. So we can ask yes or no questions. So think about a game you play. Does anybody in here play any card games? Okay. So an if statement might be, if my card is higher than my opponent's card, yes or no. So we have to break things down into those yes, no, on, off questions. And you'll see what we mean here as we start building these. So, and then finally we have what I think is probably the most powerful part of this, because it allows our computer to do something that we can't do. We can't do things over and over and over and over again very well. So think about this. If I go and all of us go leave the class, and we say we're going to go run around the building in the snow. First time around, it's probably pretty good, right? Is anybody going to wipe out on the first lap? Hopefully not. But by the 10th lap, is everybody going to be lagging a little bit? You're going to be slipping and sliding in the snow. Yeah. We don't do things over and over really well. We don't do physical things over and over really well. We don't do mental things really over and over really well. If I ask you to add up a set of numbers, you'd probably get a pretty good job the first time. But if all day long that's all you did was add up columns of numbers, are you going to start making mistakes at the end of the day? Yeah. The computer, though, it's pretty dumb, only understands 0 or 1, but guess what it can do over and over and over again? It does the same thing, exactly. So loops are our friend. That gives us the ability to do things over and over again. And that's why I think a computer is really powerful. So there's a lot of different terms for loops. So iteration is one you may have heard. We're going to iterate through this loop multiple times. So we only talk about loops in general. If we were in a formal computer science program where you were doing all the math courses and you were having to do a lot of stuff, you would find out that there's actually 6 different types of loops. But for now, we're just going to call these a while loop. Because what this loop does is while something is true, it loops. So notice what happens. It really is that decision, isn't it? It makes that question. And instead of just passing down, it goes back up to the top of that decision tree. And we can do something in that yes statement. So let's think about a thermometer. That thermostat right over here asks a question. Now, I don't know how often it asks that question, but I'm going to envision that it asks it maybe once every second. And so every second, it says, is the temperature in here 71 degrees or greater? It asks that question, and then if it doesn't get the right answer, it says, I'm going to turn on the heat. And it loops back over until the temperature is at 71 or whatever degrees we have set up. So we get this to loop over and over again, different things. And we're going to work on those. But what these are powerful, those 3 little modules, we get to stack them. We can connect from one data module to another. So when I stack these, I connect them like those Lego blocks. So these are my 3 Legos. So when I put them together, I can get a little more complicated program. So here's an example of what we call structure. I've just snapped, if you notice, each one of these connects at the endpoints. Where we had those little start and stop terminators, think about them at the end of each one of these little blocks. And so here, we say that this is structured because we can connect them end to end to end. So we have a sequence up at the top. That sequence ends, and the selection begins. Once that selection is done, we have a loop of some sort. Now, we don't know what this program's doing, but we can see the logic of it. So, if I look at the pseudocode for it on the right-hand side, so we do step A, step B, and then that selection we're going to write in pseudocode as an if statement. So, if condition C is true, we do step D. Else, we do step E. So, we can either do a true or a false. So else really says that other piece. And then our while loop we write is a while. We know it's a while loop. So while condition is true, we're going to do step G. So while the temperature is below 71 degrees, our condition is the heater's turned off. As soon as it gets up to 71 degrees, it exits out of that loop. So as soon as we don't need any heat, we exit out. So that's the way everything we're going to do is built on, those three pieces. That's it. If you can understand a sequence, a selection, and a loop, you got this down. Those are pretty simple, isn't it? Makes sense? Is anybody going, I don't know what you're talking about. I don't understand this.
So if it's structured, the structured pseudocode, you don't necessarily need to write like the input and all that kind of stuff. Is that just different? Because the ones from last week were like actual.
This is just an example. It doesn't have any. So step A, step B. There could be in that sequence inputs and outputs. They're just not listed in here. So it could be all different kinds of things. A sequence could be inputs. It can be outputs. It can be processing. So this is just to show that basic structure. So we'll show some that are a little more involved. So here's where that indents start to come into play and be kind of important. Because I can also do something a little more complicated. So I can connect those Legos end to end, but I can also put them inside of each other a little bit. So in this case, I've nested in. So notice I've really got a structure there, a sequence, inside of a selection. So here I put them together. So think about that, our thermostat that's calling for heat. So not only does it call for heat, so step J might be we turn on the heater. Step K might be we flash the lights. And step L might be we turn on a horn. So make sure everybody in the classroom knows that heater's on, right? That would be silly, but that's an example. We're just adding pieces inside of it. So we can do multiple things inside of one another. So we nest them together. We also get this term block. And so I started to emphasize that indenting. So if I look at my pseudocode, my condition that if condition H is true, then notice I've blocked out with an indent step J, K, and L. And by indenting them, that says that's a block. That entire thing has to run. So I can even nest other structures in here. So here I have a selection or a question nested inside of a question. So this is a way we solve issues that binary doesn't necessarily answer for us. So all I can do is ask a yes or no question. But I can ask a series of yes or no questions to get to my end result. So my output, I want to find out how many female athletes there are on our college campus. So I actually have two things I'm looking for, female and athlete, right? So imagine this coming in. So my first question is, are you female? If you answer no, you come down here, right? So that eliminates all the males, right? But if you are female, I'm going down this list. And so I go to step J, and maybe that step J is, congratulations, I have another question for you. Are you an athlete? And if yes, it's going to create a loop of some kind. So we can ask multiple questions. And so we can nest pieces inside of each other. So in this case, now we've nested a loop within a sequence within a selection. So these can get kind of complicated. But what we're trying to do is give us a way that we can evaluate based on the fact that we really only have those three things. No matter how we do that, we really only have those three pieces, right? We have a sequence, we have a selection, and we have a loop. So, how do we tell when something is structured or not? So, we can nest them together. We know we can do that. But even when we nest them together, they can only be connected at the top and the bottom, their entry and exit points. So each little piece is separate. So a program can have one or all. So the program you guys just wrote, that we wrote to figure out net pay, is a structured program. It doesn't violate any of the rules. Did it have any loops in it? Did it have any selections in it? It was just a set of sequences, right? One set of sequences. It's by definition then a structured program. So those are our three structures. So if you can visualize those and how we put them together, we can look at any kind of code out there. So a sequence, a selection, and a loop. That's it. Everything we're going to do in this class, we use those three pieces for. Those are our Legos. Those are our pieces we connect together. Now, we have some other things we need to add to that about how they work and how we're going to start doing them in code. But the reality is that's all we have are those three pieces. That's it. So if I look at, for example, our homework for this weekend, when we're going to have our 0 to 97 inches of snow, once again happening on a Friday. So no snow days for anybody here, right? You guys are all sad about that? A snowstorm on the first 2 weekends, but no snow days. All right, so you're going to have a quiz, and you have an assignment this week. So your assignment says you're going to create and submit a structured flowchart and the pseudocode. So you have to do both pieces, and you have a list of problems you can use. So you're going to draw a structured flowchart or write a structured pseudocode describing the steps a retail employee should follow to process a customer purchase. Include at least 2 decisions or selections in there. So, how many of you worked retail before? A couple of you. How many of you bought anything before? That should be everybody's hands. You guys have all bought stuff. We know how that process works. You can write one for the game of rock, paper, scissors. Everybody's played rock, paper, scissors, I hope. Or we could do it for the television show Deal or No Deal. Is everybody watching Deal or No Deal? So we're trying to unravel what the programming code would be if you're trying to break that down. So based on those 3 Lego blocks, that's all we have, are those 3 Lego blocks, how do we start breaking those programs down? This week shouldn't be that hard. We do have this assignment, you do have a quiz. And again, you need to make sure you read chapter 2 in that book. All right. Any questions about the homework from last week? I should have those all graded hopefully tonight at some point. Once I work through 7 hours of homework with my child tonight. We should be able to start on those. All right. If there are no questions, I'm going to stop.